And now we're going to look at graphing absolute values of parabolas. It's exactly the same idea that we're going to use either method 1 or method 2. In fact, we're going to use method 2 more often. We're going to graph the parabola first. Wherever the y values are negative, we're going to reflect them over the x-axis. So our method we're going to graph the inside first, and the inside in this case is a parabola. So if we look at A, if I just take away the absolute values, I've got negative 2x plus 2 all squared plus 2. So this is a nice review of parabolas. Okay? So it's a good unit in that way because it helps you review some of the units you've known before. What's the vertex? Negative 2 and 2. 1, 2, 1, 2. We've got negative 2 and 2 as our vertex. Does it go up or down? Go down. It goes over 1, down 2. Over 1, down 2. Those are going to be our critical points at negative 1, 0 and negative 3, 0. And then over 1, down 6. So you would have 0, negative 6. The parabola would look like this. Then right beside this, we're now going to graph the absolute value of negative 2x plus 2 all squared plus 2. So what happens is all of the places where your original function has positive y values are going to stay exactly the same. So we're still going to have that vertex, which was at negative 2, 2. The y value is positive. Our critical points at negative 1, 0 and negative 3, 0. This part of your graph stays the same. But the other part of your graph is going to get reflected up. So this point that was at 0, negative 6, the absolute value would make your y value positive, 0, 6. And so you would have that part that's negative get flipped up. Looks like a W. All right, so the domain is still everything, but your range is bigger than or equal to 0. So we graph the inside function first, and then wherever your y values are negative, they get reflected up over the x-axis, and then you've got your absolute value graph.
Wait, so is the range always going to be y?
Not necessarily, because I could have had a parabola that was down here to begin with, all negative, and then it would get reflected up there. So not necessarily. But it does seem that way. A lot of times your range on an absolute value function will be y is bigger than or equal to 0. So let's look at part B. Let's graph the inside function first. Well, on this one, yeah, they don't give you very much room at all. Maybe you can do it on the other, on page 616's column. So if I graph the inside first, what is the vertex here? 0 and negative 1. So this is going to answer your question very nicely, Nick. Does it go up or down? It goes down. So we go over 1, down 3. Oops, over 1, down 3. The entire graph is below. It has no x-intercepts. When you do the absolute value of this one, the whole thing is going to get flipped over. So instead of having 0, negative 1, 0, positive 1, instead of having 1, negative 4, 1, comma, positive 4, and negative 1, positive 4. Notice it's only the y values that get changed. The y values become positive when you flip this one over. And the question was, is the domain is still everything. Is the range always greater than or equal to 0? No. In this case, the range is greater than or equal to 1. So we can do 5b, 7b, 10, C, and D, and 15.